In this section, I want to talk about the chemical senses. So, we call taste and smell chemical senses because these senses pick up on chemicals that are either from that we digest or that we put into our mouth or that we inhale through our noses. We are dealing with chemicals that are causing the sensation. So, gustation or the sense of taste is detected through taste buds. So basically, we have these structures that are on the tongue that are these little bumps that we can see. Now that's not the taste buds itself. They actually contain where the taste buds are. So you can't actually see the taste buds. But these taste buds contain chemical receptors that when you put a substance in your mouth, and especially when the saliva starts to dissolve it, then it can interact with these receptors that are mostly located on your tongue, though there's also some taste receptors in other parts of your mouth as well. So, taste information travels mostly through the facial nerve. There's more than just one way, but it travels to the thalamus, and then it travels to the primary gustatory cortex, which is located in the back part of the frontal lobes. Now, interestingly, when we're talking about the brain, for all the other senses, the opposite side of your brain processes the information. So if you see something on the right hand side, the left side of your brain processes it. If I touch something with my left hand, then the right side of my brain processes that somatosensation. But when it comes to taste, then the if something is interacting with the right side of your tongue, it is processed by the right side of your brain. Now there are five main tastes: sweet, sour, salty, bitter, and umami or savory. Now, you might have learned in grade school about the tongue map, and that there's certain areas in your tongue that are responsible for tasting sweet or bitter or sour. This is not true. All parts of your tongue can detect all types of taste. Now, there is some slight differences in the sensitivity of one area of the tongue, especially toward the back, toward things that are bitter. But it doesn't mean that the front part of your tongue can't taste bitter or the back part of your tongue can't taste sweet. This is a misconception that has lived in textbooks for 100 years. That was actually it was incorrect at the beginning. It was a simplification of the research that they even had 100 years ago, and then it just kind of grew had a life of its own, and it became more and more extreme that we could only taste certain things in certain parts of the tongue. So that is not true. Also, research has suggested that there's possibly some other taste that exist as well. There's some pretty good evidence that we have a specific taste for fat, for fatty foods. But there's also some evidence that we might have a taste for alkaline, which is kind of the opposite of sour, and for metallic and for watery. Now, taste is the sensation. Taste is the chemicals in your mouth that are being dissolved by your saliva and interact with your taste buds. But when we're thinking about whether or not food or drink taste good or that we enjoy it, we're really thinking about its flavor. And so flavor is the perception that we get. And it's not just based on the sensation of taste. Flavor is a more complicated a sensation, or rather a perception, that's based largely on taste and smell. So if you've ever had a cold and a stuffy nose and things don't taste as good, well, that's because you're not able to have the olfaction, the sense of smell, contribute to the flavor of the food. And there's things beyond just simply even taste and smell that interact with our perception of food. This could be the temperature of the food. There's some things when it's cold just don't taste as good. On the other hand, there's some things when it's hot are not as good as if it's cold. Um, the texture of the food. Some people might find something that's really slimy, or something that's really crunchy, or really, the textures that you can have contributes to what we think about the food. The visual appearance of the food, whether it just looks like it's going to be good or not. You think you really see this with kids who just look at something and completely turn their nose up. I don't even want to try it. So that's already going to affect what they think the food is going to taste like. Pain, as in like spicy foods that actually activate pain receptors, also goes into the overall flavor of the food. Prior conditioning of the mouth, and the health states of the organism. All these things can go into what we think of when we think of the flavor of something. So, the other chemical sensation is the sense of smell or olfaction. And so, we have this olfactory epithelium, which is this thin layer of tissue that's deep in your nasal cavity, that contains olfactory receptors. So you have these kind of little hair like receptors whose job it is to interact with chemical molecules that are odorant. So if you are smelling something, that means that some part of that has to then interact with your nose. So think about that next time you smell something that is particularly disgusting. Um, so the olfactory bulbs are the structures in the from coming from the brain that these these hair receptors then interact with in the nasal cavity. So they're going to turn that information into neural impulses, and it's going to enter into the brain through those olfactory bulbs. So then smell information then travels through the olfactory nerves to the primary olfactory cortexes, which is part of the limbic system of the brain. Now, the sense of smell is an evolutionarily older sense. And so, therefore, it existed before a thalamus really existed. So, it's the only sense that we have that bypasses the thalamus. It goes directly to the parts of the brain that it interacts with. Um, and it's, yeah, to various different parts. So when it goes to the olfactory cortex, or you're making sensations of it, going to the limbic area, you have emotional reactions that are associated with smell. So when we're talking about smells, there's thousands of these olfactory receptors, but there's only about 350 types of them. And so each receptor responds to different types of odorants. So this is estimated that humans can distinguish more than about a trillion different types of odorants through their interaction of these about 350 different types of receptors for this. Now, humans are kind of average on the smell. You can think of an animal like a dog, who is much more has a much keener sense that there's a larger part of their brain dedicated to this, and can smell many more things than what a human could. So the perception of smell is processed in the brain, and we make our decisions of whether it is pleasant or is not pleasant. The intensity of it is processed in the amygdala of the brain. This is the area of the brain that processes emotions and plays a role in memory formation. And so this can lead to some of those things where you walk into a place and it's like, ah, it smells like home, or it smells like holidays, or those kind of things. So smells can be very triggering in a way that can um, uh, help recall other times when something smells in the same way. Now, that being said, most people are actually pretty bad at identifying odors by name. You have them smell something and you say, "Hey, what is this?" Most people are not particularly good at doing that. And on average, women do tend to have better senses of smell than men.